I will be talking about, this is a continuation of what Magnus was presenting, so it's going to be specifically about this machine. So one of my inputs into this project is to control the crane. So in Sweden, I'm well known for being one of the only ones that can actually automate these kind of cranes. So my part in this project is specifically that if you have a machine capable of recognizing whatever task it's going to make, then you still need a way that this machine can do the work. So usually, in this case, in forestry machines, it's a crane. In the example that Magnus was showing, this crane was doing some forwarding task. So now the question becomes, how can you fully automate this? So the forestry cranes, they are related to industrial robots. But the only difference, or I would say the biggest difference between them, is that forestry cranes are very bouncy. So this behavior that you see, they're very bouncy, they oscillate a lot, and it's because they are meant to be like that. So they are hydraulic and they are meant to be like that because of the amount of load that they have to handle. If you make them too rigid, these machines would break quite easily. So what I'm going to show you from this point is the work that is being done for these cranes. And it's not something that we have done in just a couple of years. This is a result of almost 20 years of work. And a lot of this work that you are going to see is become products of some of the companies that produce these machines today. So the versions of these softwares that I'm going to show you, the latest versions of this is what we have in the AURO machine. So they are a more evolved form of algorithms. So in order to automate the crane, the first thing you need to do is to remove these oscillations. And here you see an example. This is the year 2007, I believe, where we were first starting to understand what these cranes are doing. And what you see there is exactly what they do. They bounce a lot. But eventually, when we started developing something that today is called as the smart flow control, these cranes started becoming more easier to be manipulated by a computer. And that's what you see in the right side. So taking it a step forward, so if you really want to force the machine to do some like dramatic work, so what our algorithm can do is to fully try to make it easier for the computer to control it. So listen the words when I say easier for a computer to control it. So in the AURO machine, so this is the AURO machine, one of the biggest problems is that when the crane moves, let's say you just let it drop from there, you will have the problem that the entire vehicle will oscillate. And it can also even tilt forward if you do it with load. So the latest versions of this algorithm is something that can learn what the machine is capable of doing. So it completely eliminates any form of oscillation in it. You can just see it there. And not only that, like if the crane, if you see, it's gonna move a little bit again. In this last one, what you are seeing is when the crane has learned how to control the grapple. So it's starting to move and it understands that there is something that is doing some strange behavior like that one. And eventually it says, okay, I gotta calm this down. And then the algorithm thinks how to make it better. So through something that is artificial intelligence, it comprehends it. And then it starts moving, the way you see, without any form of oscillation and at very high speeds. So that is the first part. You remove the oscillation. The second part is that then once you can remove it, you want to make smarter movement. So that means that you, like the same way that a human moves, you tell the robot that you want it, for example, to move in a specific way. Here you have a circle. And this was experimented in the year 2004, 2005, where we could accurately control the movement of a fully hydraulic machine like this one. So what you will see is this plan that I'm planning a circle, then this machine eventually executes this plan afterwards, just as I specify it. And in the latest versions, we work with some 3D printed systems that we develop here. And these are the kind of controllers that are now implemented in the AURO machine. And an example you can actually see here, where we tell the crane to follow that kind of circle, and then the controllers actually made that happen. So you first remove oscillations, then you smartly move the crane. So the last thing is how you tell the machine what you want to do. And this is something that we have done, I believe this was the year 2010, where we put sensors on machines and we send them to the forest to work with people. So we recorded people working with these machines. So what you see there is the recording of that. So it's just replication, but this was done in a real machine. And that eventually tells you how these machine operators are controlling these cranes. So well, back then we used to call it just artificial intelligence. Today people want to call it machine learning. But this is what happens when a machine has learned. So afterwards, the computer itself is starting to plan the work. And that is something that we have computerized now. And whenever we are given anything to do, like for example, grabbing a log, this crane can actually plan that movement. And because it has all the other controllers in it, it can actually grab the log accurately. So that is what in the video that Magnus was showing, that is specifically how this crane has been able to do fully autonomous forwarding. And if you are interested in seeing it, there is a YouTube video showing all these experiments. So that's all.